lecture series of data structures. In today's class, we are going to study about that what is an abstract data type and what is a stack. So already in the previous lecture, I told that what is the data structures and types of data structures and ADT. So the abstract data type is nothing but it is a combination of a certain domain values and the operation that can be performed on that values. For example, consider integer is an abstract data type. So in that integer, so for example, you are declaring one variable as an integer means what are all the information that variable can be hold means. So the value of the variables and also what is the operation that the variable can be performed. That can be the two things it is used in that hold by the corresponding variable. So that is call it as an abstract. The abstract is nothing but in abstract data type, certain object is performed based upon the operations instead of on some things. So we can add or delete anything can be done in that object in through one operations only. That is call it as an abstract. Stack is an abstract data type. Already you know that what is a stack. Stack is a linear data structures. That linear means for every node we have a single successor and single predecessor. That is a linear data structures. So the stack, the elements are arranged in sequential. It follows the principles of last in first out. For example, consider the right hand side. The example of the stacks are the piles of books and there is a bookshelves. For example, in our dress shelf, arrangement of dresses in our dress shelves and piles of plates. So in that piles of books and in the order of that books, the first book, the last inserted books that can be deleted first. So that follows the principles of last in first out order. So the arranging of coins and books are the examples of that stack. So the stack can be done in terms of operations. It is also this abstract data type. So that stack can be operated in terms of an operations like push and pop. So what is a push means? Inserting the element into the stack. It is called it as a push operation. For example, you are going to insert a new book in that piles of that book tray. You have to insert in the top of that plate. So the top of that piles we have to insert the book. So the inserting operation done at the top. Next is a pop means the deletion operation is called it as a pop. So pop is deleting an element from the stack. So the insertion and deletion or push and pop is done only at the top of the stack. So in the stack we have used that top pointer. So the initial condition of the top is for the empty stack, top is equal to -1. Next we have two important conditions in that insertion and deletion operation we have to consider. First one is that overflow condition. So what do you mean by that overflow means? Suppose the stack is full. We are going to insert the element in the full stack means there is an overflow condition. For example, consider the stack contains 5 elements. In that right hand side already that stack have 5 elements. Suppose you want to insert one more element means we cannot insert that element. So the condition is called it as a stack overflow. That is called it as a stack overflow. So before inserting any element, we have to check whether the stack is full or not. Next is an underflow condition. So in that underflow condition is applicable to the deletion operations. So what is an underflow condition means? Suppose you want to deleting an element from the empty stack, it is called it as an underflow condition. So before going into delete an element, we have to check the condition of whether the top is equal to -1 or not. So what is it? Top is equal to -1. For the empty stack condition, the top is equal to -1. So before doing the any deletion operation, we have to check whether the top is -1 or not. If it is not means we can delete an element. That means there is an element in the stack. So these are all the two important conditions we have to check before going to do the insertion and deletion operation. Next is then what are all the ways we can implement the stack operation means. One is that array implementation of the stack, other one is the linked list implementation of the stack. So for every data structures there is a two implementation part, array and linked list. So array, already you know that what is an array implementation. Array is a sequence of it is a set of it is like a container. So in the array the elements are stored in the sequentially, and the deletion it can be done in the sequence order. So one of the way of implementing ADT is an array implementation. Next one is a linked list implementation of the stack. So what is a linked list means, so instead of using a static allocation, array is a static memory allocation. So once you fixed the size, we cannot change that size of an stack. So instead of doing that dynamic memory location, we are going to use the linked list implementation of the stack. So the linked list implementation mainly use the pointers. So for every node in the linked list we have a for example, consider the simply linked list. For every node we have a two important things. One is a data part, other one is a link part. So the data part hold the address of that for the data part store the value of that variable, and pointer part store the address of the next element. So for every element we have two parts. One is a data part, other one is a pointer part in the linked list implementation of every data structures. So in this video I am going to tell about, I am described about that what is a ADT and what is a stack, and introduction to the stack, and two important operation in the stack, and two important conditions we have to check before to inserting in the insertion or deletion operation, and how we can implement the stack in two ways. I hope you will understand what is a stack and its implementation. In next video we will see the array implementation of stack.